Alright class, so we move to the next subtopic, which is subtopic 6.2 Cyclic Quadrilaterals. So what is a cyclic quadrilaterals? So as you can see from this figure, this is the cyclic quadrilaterals. So a cyclic quadrilaterals is a quadrilateral in a circle where all four verticals of the quadrilateral lie on the circumference of the circle. So if I mark this E, F, G and H, so I can say that E, F, G, H in the diagram is a cyclic quadrilaterals, and the angle of E and angle of G same goes to angle of F and angle of H, known as opposite angles in cyclic quadrilaterals. Okay, let's proceed. Let's do a little bit of practice. Alright, as you can see the question A. So from the figure, you can see that one of the verticals lying outside the circle. So what do you think, class? Is this a cyclic quadrilaterals? The answer is no, because one of the vertical is lying outside the circle, so all the four verticals must lie in the circumference. Next, look at question B. So B is a cyclic quadrilateral because all the verticals lie on the circumference. How about C? Okay, as you can see, there's only 3 verticals lying on the circumference, and the other one is lying on the center of the circle. So C is not a cyclic quadrilaterals. How about D? So D is obvious. D is the cyclic quadrilaterals because all 4 verticals lying on the circumference. How about E? So E is almost same as C because only 3 verticals lying on the circumference, but the other one is lying on the center of the circle. Therefore, E is not cyclic quadrilaterals. How about F? So F is a cyclic quadrilaterals because all the verticals lying on the circle. Right, next. So as you can see from these figures, so the sum of the opposite interior angles in the cyclic quadrilaterals is 180 degree. So which means that the angle of F and angle of H total is 180 degree, and also angle of E and angle of G total is 180 degree. So let's do a little bit of practice. Right. So as you can see from the diagram, shows a cyclic quadrilaterals of A, B and CD. So calculate the value of X and Y. Okay, so as you can see, there are 4Y and 8X. So as what we have learned just now, the sum of the opposite interior angle are equal to 180 degree. So let's solve x first. Okay, so the interior angle of BAD and BCD are opposite in cyclic quadrilateral. Opposite in cyclic quadrilateral. Therefore, these two angles total are equal to 180 degree. Therefore, if to solve x, then add x, bring to the right side, then x is equal to 9.5 degree. Alright, so we move to y. Okay, so we look at the angle of ADC and angle of ABC. Both of those angles are opposite in cyclic quadrilateral. Therefore, the total of these two angles is equal to 180 degree. Therefore, solve y, 4y plus 98 degree equal to 180 degree. Therefore, bring the 4 to the right, then divide by 4. So y is equal to 20.5 degree. Alright, let's move on. So now we're gonna learn about the relationship between exterior angle and interior angle. Okay, let's look at this figure. Alright, so the diagram shows a cyclic quadrilaterals of DEFG. The chords DE is extended to H. So angle H, E, F or angle X is an exterior angle of cyclic quadrilaterals DEFG. So angle DGF or the angle of Y is the opposite interior angle corresponding to X. Okay, next. As you can see from this figure, the diagram on the right shows a cyclic quadrilaterals ABCD and a straight lines of CDE. So calculate the value of y and value of x. Therefore, in order to find y, we need to know this angle. Therefore, since this line and this line are equal, so this angle CAB is also equal to 48 degree. So now we can find y. So y equal to 180 degree minus 48 degree and minus another 48 degree. So y is equal to 84 degree. So since x is the exterior angle and y is the opposite interior angle, so x is equal to y. Therefore, x is also equal to 84 degrees. Alright, next. So the diagram on the right shows a cyclic quadrilaterals of PQRS and straight lines RST. So calculate the value of angle PST. So in order to find value of PST, we need to know the value of y. So from the previous we learned that the sum of interior opposite angle is equal to 180 degree. Therefore, 4y plus 2y is equal to 180 degree. So we know that y is equal to 30 degree. Therefore, we need to find the value of angle of PQR, because angle of PQR is equal to angle PST. So we need to calculate the angle of PQR. So PQR is equal to 4y. 4 multiplied by 30 degrees. So angle of PST is equal to 120 degree. Alright, next we learn about new subtopic, which is subtopic 6.3, tangent to circles. Alright, so what is tangent? So tangent to a circle is a straight line that touches the circle at only one point. So the point of the contact between the tangent and the circle is the point of tangent. Okay, next. So determine the following straight lines, and the point shown in the diagram are tangents to the circle. So as you can see, there are only two straight lines in this diagram. So this line is the tangent because only one point touches the circle. Okay, next. Example 2. Right. So as you can see, there are three lines, and these two lines connected to each other, but doesn't matter because tangent is straight line that touches circle at only one point. Therefore, this line is tangent. Same goes to this line. Okay, next. So you can see from this figure there are three lines that connect each other at the end of this point. So this line is a tangent. Same goes to this line because it only touches the circle at only one point. Alright, next we move to class activity. So this is a group activity. So the aim of activity is to determine the properties related to two tangents to a circle. So the materials are drawing papers, compasses, protractor, ruler, and pencil. So step 1 is to draw a circle of a radius 3 cm with a center O, and then draw a straight line of 8 cm from the center O and label as OA. Then we move to step 2. Draw another circle of radius 7 cm with point A as center of the circle. So start from here. Draw a circle of radius 7 cm, and then mark the intersection point of both circle as BC. So here's B and C. So draw a straight line of OB, OC, AB and AC. So here's it, the straight line. So after you draw, you can measure the angles of this point, each angle from inside of this region, and also the length of the lines. And then after you record or measure all the angles and length, you can display your group finding in the mathematics corner and compare your group answers with other groups. Lastly is to discuss what are your group conclusions regarding to the angles and length that you have measured. Okay, right, so now I'm going to show you a little bit of demonstrations about the group activities. So you merely need the compasses, projector, ruler, pencil and also eraser. So next, I think it's better for you to draw a straight line of 8 cm first. So that it's easier for you to start to draw a circle from point O and A. So make sure this radius is 3 cm and this radius is 7 cm. After that, the step requires to mark the intersection point. Then connect the point with a straight line. Then you can label the angle. So I try to label this angle. So the angle is 60 degree. Then I also label from this below, and the reading is also 60 degree. So the angle of QPR and angle SPR are equal. So after you measure your angle, you can record it in this table and also the length of each point. And not to follow my measurement because this is just an illustration. Okay, next, as you can see from this figure, the radius and the tangent which intersect. So the radius of the circle that intersect with the tangent to the circle at the point of tangency will form 90 degree with the tangent. So it's mean that not from the circle only, but from the tangent, the angle from the tangent to the radius here will form 90 degree. So next, so here's the example. The diagram on the right shows a circle with center O, which meet the straight lines of ABC at point B only. So calculate the value of x. As we have learned just now, if the radius intersect at the point of tangency, therefore this angle will be 90 degree. So angle OBA will be 90 degree. So in order to find x, 180 degree minus by this angle and also this angle. So now we need to find this angle first before we find x. So this angle AOB. So angle AOB equal 180 degree minus 138 degree equal to 42 degree. Therefore this angle is 42 degree. So now we can find x. So x is equal 180 degree minus 90 degree and minus 42 degree equal to 48 degree. Alright, next. So if two tangents to a circle with center O and point of tangency E and G meet at point H, then EH is equal to GH, which means both of these lines are equal to same length. And then angle of EOH and angle GOH are equal. So these two angles are also equal. Then angle OHE and OHG are equal also. So these two angles are equal if two tangents of the circle with center of O and points of tangency EG meet at point H. Okay, next. So the diagram on the table shows a circle with center O, tangent PQ and RQ met at point Q. So calculate the value of x and y. So as we know that this angle is 90 degree. Therefore, to find x is 180 degree minus 90 degree and 66 degree. So x is equal to 24 degree. So now is to find y. So since PQ is equal to RQ, so y is equal to 10 cm. Okay, next. Alright. So as you can see from this figure, angle X is equal to angle Y, and angle A is equal to angle B. So the exterior angle is equal to the opposite of interior angle. So because the angle between the chords and the tangents are equal to the angle at alternate segments subtended by the chords. So let's find this value. Find x and y. So I guess you all might already know the answer because it's obvious. X is equal to 50 degree and y is equal to 71 degree. Right, so okay, so that's all for this video lesson.